First of all, thank you very much for the organizer for putting such a great program, for allowing us to present this talk in front of this audience. I'm going to talk about, in the next 12 minutes or so, about open data in whole slide imaging, and really I'm going to talk about a much wider consortium, and a lot of the work I'm presenting is actually the result of a joint result of academic and commercial entities, so that's University of Dundee and Glencoe Software. So I'm part of the university, the Open Microscopy Environment, which is an entity which has been existing for now 20 years, which attempts to solve in the life science and biomedical domain the problem of imaging. And the problem of imaging can be expressed quite simply via this slide. Images are generated by all kinds of scientific institutions. This is an extremely rich and valuable resource. The problem is that what an image is effectively extremely heterogeneous. So different instruments, different entities are generating images, and you need tools in order to be able, so this slide summarizes a couple of the modalities we are dealing with routinely. It goes from the fluorescence microscopy, digital pathology, or high throughput screening, and you need tools to be able to consume all these images in a unified way via resources. So I'm going to focus a lot on digital pathology now, but obviously a lot of what I'm talking about actually applies and mirrors in other domains of bioimaging as well. And a fundamental problem that exists everywhere is the problem of proprietary file formats. So as you all know, imaging is generated by instruments, most usually generated by commercial entities, but also academic. In the case of whole slide imaging, so these are scanners, and scanners, as you all know, create these very large slide images, so very large in the X and Y dimensions. And in order to be able to deal and work and manage these images, the typical way to do that is to create downsamples versions of these very large base images, which are called resolutions, and that creates a so-called pyramidal image. So that's what you see when you zoom in and out of your image. So all these instruments are very nicely generated, all these improved images. The problem is that they're all storing it as of today, more or less in their own proprietary file format. So essentially, when it comes to the user, may it be a pathologist or may it be an analyst who wants to look at different resources, how does this person access all these different file formats? And the solution, at least in the open source world, I mean, a set of solution has been to create open interfaces, so that's libraries, that's software that sits in between your file formats and your consumer, your user, and allows you to effectively seamlessly, independently of the vendor, access, obviously, the pixel data, so all the pixels that we talked about, but also all the metadata that's stored in the original file format. And as open source libraries, there's really two main, which are predominant, at least in the pathology world. One of them is the Open Slide Library, which has been built by the Carnegie Mellon University, and Bioformats, which has been developed by OME. So a priori, this seems to be solving part of the problem, but really it's not. It's not because it's not a sustainable model. Effectively, open source libraries, so first of all, the first problem is that none of these libraries does a complete job. You don't have a library which offers full support for all the ecosystem of file formats that are out there, or all the variants of the file format. And generally, trying to keep up with the evolution and the proliferation of file format is simply not a sustainable job for software which is largely funded by academic grants. So the problem is essentially what we've established is to start having the community agree on a set of open community-based file formats which will be exchange mechanism that everyone can consume, may it be academic and also commercial entities. And in the life science and biomedical domain, we introduced OME TIF something 10 years ago. So the idea is, first of all, obviously to use open specification. So we use the OME for the metadata, and we use TIF, which is what a lot of manufacturers are using for storing the pixel data. These open formats need to be available. So they need to be obviously public specification, lots of examples, but also software for reading and writing and validating these tools is extremely important. It needs to capture, I mean, obviously a lot of modalities, I'll come back to that, and there has to be a commitment to long-term support. We want data that's generated today to be readable and usable 10, 20, or 30 years from now. So OME-TIF has been introduced in the, again, in the more or less confocal microscopy domain. We've already extended it for high content screening. There's a huge support by at least a lot of commercial entities which are using it as an export format. And we've looked at what it would take to essentially have this format also be an exchange mechanism for supporting whole slide imaging. And when I'm mentioning whole slide imaging, I'm really thinking of multiple modalities here. So you've got the classical bright field tissue images. We've seen a lot of that. This can be expressed as different Z-stacks. But what we've seen growing, especially in the last years, is the arisal of multiplexed imaging. So that's fluorescence imaging, where you have lots of hyperspectral planes. You have now 2 to several tens or even hundreds of channels that need to be analyzed that way. Also, if you start looking at other domains, so here beyond digital pathology, for example, this is a transmission electron microscopy image of a zebrafish embryo that's probably one of the largest image in the world, large stitching, and these kind of other domains also need solutions to be able to address that. So what we've tried to do, especially in the last year, again, is trying to look at what it would take to extend the existing OME-TIF format to support all these different modalities. So we've mostly looked at that, looked at how to use the existing TIF specification and already existing extension. We've proposed a new implementation, and we've started to validate and test it, again, against this set of different modalities. So we've taken public representation of all these different modalities. We've updated our own reference library, which is bioformats, to essentially support this new updated specification. We've converted all of these images into new style OME-TIF, if you want. That means testing the writing of the data. And then we've also tested the reading of the data, so using different applications, so end-user applications, which are consuming this library. One of them is QPath, a desktop application developed by Pete Bankhead for whole slide imaging. The other one is Homero, which is a data management system for whole slide images and other modalities. So all of that has been successful, and all of that effectively has been released now at the beginning of 2019. So what exists today in an open source way is an extended version of the OME-TIF specification, which uses some TIF specification that was proposed back in the 90s, but also an open source software, so an open source reference implementation that allows anyone to read, write, and validate these files. So anyone who is using this library can actually just upgrade their software and benefit from reading these new files. What we haven't done so far is looking at the implementation of this library in other languages, so other ecosystems that we need to look at, especially for all the manufacturer and the analysis community, but also all the relationship with the DICOM standard, which proposed the supplement 145 to do the same thing in the DICOM ecosystem. So we went yesterday and joined the working group 2026, and really looking forward to more discussion in the next few days about the state of the art and the upcoming of such alternative version. But what I want to say here is, although we have provided an open source implementation for classical 2D whole slide imaging, this is not the end of the story, because there are things coming at us, and I think there are things coming at all of us in the upcoming years. So what we're seeing from new emerging technology like light sheet or correlative microscopy are things that are fundamentally challenging the 2D pyramidal images. So this is an example of mouse cells which are imaged by light sheets, and now instead of having a very large XY image, you start having the Z dimension, so the number of focal planes being equally large, and you need to start dealing with volumes and no longer just little tiles. And this challenges existing things. This challenges TIF, for example, and formats, and we need new solutions, and we need to start thinking of new next generation formats. So there's an ecosystem of new formats. I won't go into the details, but that's probably the next thing we'll have to start thinking about, how to deal with these new modalities. In addition to, obviously, I talked about open libraries, open formats, there's also something which is coming, which is open resources. So there's clearly new upcoming image data, new public repositories coming, which ingest public data make them available via curation, via public archives, and make them usable for all kinds of purposes. So this is analysis, reanalysis, usage, or even like training. We heard a lot about training today. So we have built such, we have started building such a resource in collaboration with EBI, and as an example, we've started joining forces with the Human Protein Atlas project, taking all the tissue data that they have been working on, and which is available via the atlas, and making all the imaging data slowly, terabyte by terabyte, available in a public resource that is accessible today publicly for reusability. And if you want to know more about that, feel free to come and ask some questions. So I think I'm reaching the end of my talk. Thank you very much to your attention. Thank you very much to the founders who made these efforts possible. And I'll gladly take any questions from now on. Thank you.
Okay, thanks. Any questions?
So that's great that while the images are sort of available. So one question is that what about the annotations? Because annotations is a difficult part. Now, is there a sort of a crowdsourcing mechanism that could be, say a crowdsourcing of pathologists, for example, that could be interfaced with this to get the annotations?
So, and something I didn't show on my slide. So, I mean, in this resource, so there's different aspects of these curations. Obviously, we take the raw images, but on top of the raw images, we're also adding curated value, which means the experimental data or metadata, biomolecular annotation. So in the case of a Human Protein Atlas, we took all the SNOMED annotation that they provided, and this is also available and linked to the data. And whenever possible, also annotation, so we call that, I assume we're referring to regions, so we call that regions, there's different semantics, when available, are also available and linked to the data. And this is something that can be done, and also having it available means that others can actually start building their own analysis against the data and maybe proposing new annotations.
Okay, any other questions from the audience? I have one question.
Sure.
I think it's great to have standards, and I think we actually, our field has been hampered by the fact that we didn't have standards so far. I think we really suffer from that. I think having the standard is one thing, but now, let's say, convincing the companies to adopt your standard, of course, is the second and maybe the even bigger problem. Is there any movement in that direction that you're aware of or that you're part of, maybe even?
So, I mean, obviously, we're here to learn about how things have been doing in the digital pathology. Our experience in the life science domain is we clearly have some interaction with at least the life science department of the classical companies. And there is some movement there towards, adopting things that we can exchange and even like consuming things that exist. In our experience, providing software and providing software that we use that is open source, but that the company can also use is a key to this adoption, because then the company doesn't have to reinvent that. We can all start building this base library. The company can have absolutely their commercial work on getting the best instrument there, but then what they produce is available to the user. And from my side, the community is there. The community wants to be able to get the best instrument there, get the data, analyze it somewhere, and so they don't want to be tied to these things. So I think for us, providing solutions that not only the academics, but also the commercials can use and reuse is part of the key.
It's key to that.
Yeah.
Okay. Okay, thanks a lot.
Thank you.